relational algebra examples. So in this series, I'm going to discuss a couple of examples uh, for each of these operators available in relational algebra: selection, projection, that's project, union, set difference, intersection, Cartesian product, rename, and assignment. So I'm going to use these three relations as a guide to demonstrate how we are going to use all these operators. So we have a student, course, and the mapping table that maps a particular student to course via the student ID and the course ID. So let's see. Our first thing is it's going to be easy one. Select all student from a student relation. So the thing you want to do here is very simple. We can simply say student. This is the relation name. If you know the relation name, if you specify the relation name in a relational algebra expression, that simply says all the data from that particular relation. And let's get into a little bit advanced version of this one. Now you want to select all students from city of Dallas. The highlighted one is the one that we should get. So how are we going to restrict the number of records in this student table so that you get only records which has Dallas as the city, right? Now if you have the student table, now if you want to select a subset of the tuples or records from this relation, what you have to do is you have to use the first operator, that is selection operator, and then you have to specify the predicate student city, that is my attribute is equal Dallas, and then you need to put your relation inside a parenthesis, right? This will give you all the students who are from Dallas, right? In this relation, example relation, you have only one record, only one such a record. Okay, now let's make it a little bit advanced. Now instead of one condition, you specify two conditions, that student must be from Denton and also he must be from Texas, right? There are two Dentons here, but the state is not matching, right? So we have only one record, one such a record, right? So let's see how we are going to modify this one, right? The same thing, you need to select student city is equal Denton and student state is equal Texas. Now you need to select these all from student relation, right? The first one is giving you all the students from Dallas. The second one is giving you all the students who are from Denton, Texas. There is only one such record in this table. Now let's move on to our project operator. Project operator is simply select the specified attribute values, right? For example, select first name of students. Now if you want to select the first name of students, the operator you must use is project operator, and then you specify what do you want to get from that particular table, student first name, and then you specify what is the relation you want to student. So this will give you all the names of students, first name of students, right? John, Amal, and Stephen. Let's make it a little bit advanced. Now you want to select two different things, two different attributes from this table. That is, select first name and city. It will give you the first name as well as city from the student table. So the only difference is you add one more attribute, student F name, comma, student state from student table, student relation. All right, now we are in a position that we can combine two different operators, basically project and select, right? So we move from the previous slide that you need to select the first name and the city of students. This time we want to restrict all these tuples to be only from Texas. Okay, now what we need to modify here, we need to select the first name, student first name, that is as it is, there is no change, and then the student state, that is also not changing here because we want those two attributes. The only difference is what is the relation, right? This is not the student this time because student has all the records. I need to restrict, I need to get a subset of tuples available in the student relation. To get a subset or to restrict, to get apply a condition, you use sigma and student state is equal Texas and student. Now this one will give you a relation. That relation is working as the base relation for this project operator. So this part will give you all the students from Texas, and this will this will display the first name and the state only. So first name and then the state only if they are from Texas. So that's how you keep on adding stuff into the relational algebra expressions. Now the next one is the union operator. To apply union operator, you need two relations. So I created two examples. One is book and the article, and then book has an author, article has an author as well, right? So there can be some common values here. Stephen Kane is writing a book as well as he's writing an article, right? So there are some common stuff in both tables. Now I just want to get all these information. For example, select all authors from our system regardless of book author or article author. You need to get all the authors from our system. So the only way you can do this one is you can use union operator. Select author from book. This will give you all the authors from the book, and also select authors from article. Now you perform union between these two. This will give you all unique authors. Why unique? Because these are set operations. Okay, now if you get the union, you will get Stephen. Stephen, you have two Steve. You have Stephen here as well as here, so that you will get only one Stephen. So the resulting set will have only 5 elements, 5 names. Okay, author names. Let's do the set difference. I want to find what is available here that is not available in author. For example, select all authors who have written books but not articles, right? There must be an author who writes books but not writing any article. So that's what I want to do here. The only difference you need to do here is you can change this union operator to a difference operator, and this will subtract set of authors who wrote articles from set of authors who wrote books, right? The result set will be all the authors that are not available in article relation. And the next thing is set intersection. Intersection means find all authors who wrote both books and articles, right? So the only difference here is you simply change this difference operator to intersection operator. This one will give you authors who wrote book and articles. Cartesian product. Cartesian product is combining all the possibilities from one relation to the other relation. For example, select student along with their course ID, right? So you have students in student relation, course IDs in enrollment table. You have course IDs in course as well, course relation as well, but there is no way of combining these two. All right, there is no common attribute to these two relations, but there is a common attribute in these two relations, student and enrollment, that is student ID. Let's combine these two. Cartesian product student Cartesian product enrollment. Enrollment. This will give you all the possibilities. Regardless of whether student take it or not. For example, student ID 1 will be listed with course ID 1, course ID 2, and this one as well. This row will be listed with this one, and this one. In the final result, you will have this many number of rows into this many number of rows. For example, if we have 3 rows here and 3 rows here, 3 into 3, you will have 9 rows, 9 tuples in the resulting relation. That is what not we want. What we want is, we want to get students, all the students, and then the course IDs, those must be matching. How do we do that? To do that, we can use a condition, a subselection, right? So let's do that. I'm going to select where student dot SID is equal enrollment. Let me move this one slightly again. Okay, S must be there too. Enrollment dot SID. Now this condition will make sure that you are not getting any unrelated rows. This one will produce all the possibilities, but this condition will filter out so that 1 will match with only 1, 2 will match with only 2. If there are no matching from this student ID to enrollment, that row will be ignored. In that case, you will have 2 rows, 3 rows, 1 match with this, 1 match with that, and 2 match with this, right? So the John will be taking course number 1, John will be taking course number 2, and Amal will be taking course number 1. That's all. So that is basically applying a condition to the resulting set, and then you may need to put a parenthesis around that Cartesian product, right? This is same as, you can write the same thing as student theta join, now condition student dot SID equal enrollment dot SID where enrollment. So this is identical to this. So this is, we call theta join. This is Cartesian product with some condition. Before we move into the rename, I just want to show you how to combine all these 3 relations and then list all the courses alongside the student, including the names, titles of the course, and the credit as well. If you want to get student information along with course information, definitely you have to combine 3 tables, namely student and Cartesian product, enrollment, and Cartesian product course. But there is a small tiny issue here. These operators are binary, so what you have to do is you have to chain this, you group these Cartesian products into 2. Now this part is one Cartesian product, and this one is another Cartesian product, that part and this one, now 2, right? So this one inside is a Cartesian product, altogether you get an R, for example, and then there is another Cartesian product between R and the course. Now you get the selection condition I will shorten the name for simplicity. Student dot student ID is equal enrollment e dot student ID, and let me use a different color for that, and enrollment dot course ID is equal course dot course ID. Now this is the predicate. That predicate will eliminate all the other unrelevant information from this gigantic relation, that is the Cartesian product of student, enrollment, and then the course. So this is how you combine all these three tables into one giant table with only relevant information from student, enrollment, and course. So this will have all the attributes from all three tables relations, but only the relevant rows from all three tables. All right, hope you got that idea. Now rename operation. Rename is basically you can rename an existing table and create a temporary table with that new names. For example, if you have a customer table with CID as attribute name and city, I just want to select customers who are from Dallas as Dallas customers and rename the name attributes and rename the attributes to customer ID, customer name, and customer city. So let's see how we're going to do this. So I have customer table. So I want to rename this one as, so this is the notation for that, A1, A2 up to AN. The expression is entity expression, right? So this is the format, this is the way we write it. So let's convert this one into our example. Row customer Dallas, for example, right? So you need to rename the customer ID, CID into customer ID, comma, customer name, comma, customer city. Now inside this, instead of putting customer, if you put customer, you will get all the customers, not customers from Dallas, right? So that is wrong. So you need to put an expression inside. You need to select only customers from Dallas. City is equal Dallas. Now this whole set goes in here and act as the relation for this rename operation. So this one will give you all the customers, CID, name, and city of all the customers who are from Dallas, and then this rename operation will rename all these attributes, CID to customer ID, name to customer name, city to customer city, and then whole table name will be, the new table name will be customer Dallas, or maybe Dallas customers. So that's how you rename. Now assignment. So this is a very simple thing, like you assign one particular relation to a variable so that you can use it at a later time. So let's see what it really means. Suppose that you have a table customer. Right now you want to select Dallas customers. Now this one will assign this one to a customer Dallas. So this is my variable name. You get the result, assign that one to a new variable. Now you create another variable Tintin. Now variables called customer Dallas and customer Tintin. Now you can create another variable called customer Dallas and Tintin. You assign customer Dallas union customer Tintin. Now this is a relation and also this one is a relation. Now if you combine these two and then you get another new variable, this is also a relation. So after you assign all these relations to a variable, those variables are behaving as a relation so that you can apply any operation on those variables.